In this video, we will discuss how to obtain diaphragm chord and collector forces in ETABS. Let's get started. For this example, we will use a simple model with shear walls located at each end. First, we will need to define a semi-rigid diaphragm and apply it to the slab. We'll go to Assign, Shell, Diaphragms. Let's take a look at what D1 has been defined as. Semi-rigid diaphragm, and we'll click Apply. Next, let's assign a line load. Go to Assign, Frame Loads, Distributed, and we'll apply a live load in the Y direction. Let's quickly run the analysis. Now, to look at some output, we'll go to Display, Force Stress Diagrams, Shell Stress Forces. And we'll click on the F11 component. Next, where maximum chord forces are expected, let's draw a section cut. To do that, we'll go to Draw Section Cut, Moments about the z-axis represent in-plane moments, so we need to ensure that the resultant force angle is vertical in order to enforce a vertical line. We'll change the angle and click Refresh. Let's take a look at an image for the values we are looking for. Let's take a look at an image of the values we are looking for, in this case, compression and tension chord forces. Compression and tension chord forces are then given as the value of each z-axis moment divided by the slab width, as shown in this figure. In this case, you would take the z-axis moment and divide it by the width of this slab, which is about 20 feet. This is the integrated z-axis moment of interest. Next, for shear and collector forces located at the connection between the diaphragm and a shear wall, let's draw another section cut. Again, we need to ensure that the resultant force is vertical, and we will refresh as necessary. Given this example model, the shear collector force, which is represented in F1, is 3.84 kips. Local axis of section cuts 1 and 2 in Z are similar to a frame element. Resultant force angle indicates angle between the X global axis and the section cut local 1 axis. This same force will be obtained by reviewing V2 for the wall piers at the edge of the building. Pier forces in combination with section cuts can be used in more complex models to design and check diaphragms. So when looking at this section cuts form, for the integrated forces, the values displayed in these display boxes are the forces and moments along the right and left sides of the section cut at the point coordinates defined by the coordinates listed in the resultant force, location, and angle. You also have the ability to save the left side and right side cut. And upon doing so, you can access these cuts in any output form, whether it be a report or detailed report. For example, if we go to File, Create Report, Add New User Report, you can see that in the Groups section, this S-cut form has now been included.